Hi everyone, welcome back to the channel. Today we are going to deep dive into high availability options for VPN connections in Azure. As cloud architects and DevOps engineers, maintaining a stable and high available network connection between on-premises resources and the cloud is a critical aspect of our work. In today's video, we'll break down two key VPN availability options: active passive mode and active active mode. These options play a vital role in ensuring consistent network connectivity, especially when you are working with critical workloads that require redundancy. Let's get into it. When you are setting up a VPN gateway in Azure, a critical decision you will need to make is choosing the right availability mode for your deployment. Azure supports two primary modes: active passive mode, which is the default, and active active mode, available for route-based VPN gateway SKUs. Choosing between these models depend on your redundancy requirements, recovery time objectives, and how tolerant your workloads are to brief outages and interruptions. Let's start with active passive mode, the default setup. When you deploy Azure VPN gateway, two instances are created behind the scenes. In active passive mode, only one instance is actively handling the traffic. If there's a planned maintenance event or an unexpected disruption like a failure, the passive instance takes over automatically, requiring no manual intervention. For site-to-site VPN connections, this failover will cause a brief service interruption. Planned maintenance could result in a failover time of about 15 seconds. For unplanned disruptions, it could take up to 3 minutes for the connection to be fully restored. For point-to-site connections, users will need to manually reconnect after failover. Now you might be wondering, how do you increase reliability on the on-premises side? Well, you can introduce multi-VPN devices on your on-premises network to create redundancy. However, this configuration doesn't change Azure's failover behavior. It still operates as active passive on the Azure side. Let's review the requirements for this setup. There should be a unique public IP for each on-premises VPN device. Also, the border gateway protocol is a must. Each on-premises device should have a unique BGP pair IP. You will also need ECMP, equal cost multipath routing, to ensure traffic distribution across the available VPN tunnels. This setup offers more resilience on your end, but remember, Azure will still have a brief failover time. Now let's move to active active mode, which offers increased redundancy and availability. In active active mode, both VPN gateway instances actively handle traffic. Each instance has its own public IP address, and both instances establish simultaneous VPN tunnels to your on-premises VPN devices. Here's where it gets interesting. When traffic flows from your Azure VNet to your on-premises network, Azure will load balance traffic across both tunnels. If one of the VPN instances experience an issue, whether planned maintenance or an unplanned event, Azure will automatically reroute traffic to the other instance without any need for manual reconnections. This provides near zero downtime, especially for site-to-site connections, as traffic is automatically shifted to the still active tunnel. For maximum reliability, you can implement dual redundancy on both sides, Azure and your on-prem network. This creates a full mesh topology with 4 IPv6 tunnels, providing always-on availability. Even during planned maintenance, you will have a pair of tunnels available to handle traffic. Here are some key requirements for active active mode. As with the active passive mode, BGP is required to manage the routing of these dual tunnels. Both VPN tunnels need to be configured to handle the same network prefixes with equal priority, ensuring a smooth traffic failover. Now that we have walked through the technical steps of both availability modes, let's compare the key differences and when you might want to choose one over the other. Active passive mode is a simple and works well for applications that can tolerate short outages. The failover time is acceptable for less critical workloads, but for mission critical applications, the downtime might be disruptive. Active mode, on the other hand, provides much higher availability with seamless failover. It's ideal for production environments where minimal downtime is a requirement, such as financial services, e-commerce, or any other application requiring constant connectivity. Before wrapping up, let's quickly go over some best practices for ensuring high availability in your VPN architecture. The first best practice is to always use BGP when deploying high availability VPN gateways. BGP helps dynamically route traffic and improves resilience during failovers. The second best practice is to implement dual redundancy in mission critical environments. Having redundancy on both sides, Azure and on-prem, guarantees that you always have an available VPN tunnel, even during maintenance or unexpected outages. Lastly, monitor your VPN connections using Azure's built-in monitoring tools. By setting up alerts for disruption, you can ensure any failover or connection issues are addressed immediately. To wrap up, choosing between active passive and active modes depends largely on your specific use case, redundancy requirements, and the clarity of the workloads you are supporting. For businesses with high availability needs, active is the clear winner, ensuring continuous connectivity and minimal downtime. If you found this video helpful, don't forget to like and subscribe for more cloud architecture content. And if you have any questions or specific use cases you would like to discuss, feel free to drop them in the comments below. Until next time, stay tuned for more deep dives into cloud networking solutions.